everybody, thank you for joining this webinar. This is our live expert session, which is broadcasted from our headquarters in the Netherlands, Leapfrog headquarters. My name is Frank Valkenburg and I'm the account manager at Leapfrog. Today I will start with a short introduction and then I will explain the advantages of the HS. Then my colleague David, who is our engineer at Leapfrog, will take over and he is going to present how you can get the most out of your machine and out of your software, and he has some handy tips and tricks for you. Now, if you want, you can chat during the session live with Mircea Old. He is a colleague of ours from our support team. This broadcast has 1 minute delay, but the chat function is live, so you can directly chat. Also, what I want to tell you before we start, we might switch from this webcam environment to our computer to present to you from PowerPoint sheets. Sometimes we need to zoom in some aspects and it's handier to do this via our PowerPoint sheets. Further on, let me start with, the program. As you can see on the PowerPoint sheet right now, this is the program. I already explained briefly. I will start, then David is going to take over. And I will come back to you at the end. Now, as you might notice, point 6, specific customer request is not there on the program. We decided to answer your questions throughout the whole presentation. Thank you for sending us questions. Also, because we have to take into account the timetable, and we think we can answer all your questions throughout the whole presentation. If you don't answer your question, just let us know via email and we'll get back to you later on. Now, let me start with a brief introduction of Leapfrog, for those of you who don't know us. We started in May 2012 at our mother company, AV Flexologic. Now, at AV Flexologic, some engineers needed a 3D printer. They needed this 3D printer to start making customized parts, and they needed design freedom. Also, they needed to print prototypes and reduce time for this. They bought a 2D printer kit. Now, the experience of building this kit took a lot of time, and also it was a real hazard to operate this kit. So they said, well, we're going to build our own 3D printer with the knowledge we have and with all the means we have at this company. So they gathered together all the highest materials they could find, and they started to build their own 3D printer. They took the printer to a trade show where AV Flexologic was represented, actually more to show the level of innovation of AV, but it turned out that a lot of visitors were interested in this printer. It was the Creator, our first model, and this is when Leapfrog started. So we started only a few years ago, and we're now a company with around 70 people working at Leapfrog, and we sell and produce around 100 printers per week. Now, for those of you who already have a Creator 2014, I want to explain to you the advantages of the HS. Now, 3D printers, like a computer, it develops. So each year there will be faster printers and there will also be more accurate. Now, what makes the printer a new generation laptop or a 3D printer? We made some improvements on the machine. I will go over the improvements very briefly. What we kept the same is the stable base, a triangular form of 3 times ball bearing spindles. So for a very stable bed, you can actually lean on the printer and it won't change its form. Now, as you can see on the head, I don't know if you can see it, but with the Creator 2014, we had the engines mounted on top of the extruder head. Now we have the engines on the base, which makes it 3 to 5 times quicker because the head is far more lighter. Also, operating or handling the machine is much easier. We have knobs underneath the bed where you can calibrate the bed easy and fast. David will explain to you later how this works. Also, inserting the filament with the Creator 2014, you had to do it here on top of the extruder head. Now we made a patented system with this lever. You can pull on it and you can pull away the driver gear, make a gap in between, and there slide in the filament, very easy. So loading the filament is quite easy. Also, you can twist and place more tension on the driver here. We made, of course, an import for USB, so you don't have to hook the machine up to your computer anymore. Yeah, and it's also more accurate because we changed the software and some hardware changes, which make it up to 5 times more accurate actually than the 2014 model. So now I will want to welcome David, and he is going to help you how you can get the most out of the printer. Thank you.
Thank you, Frank. Hello, my name is David van den Bergen. I'm an engineer at Leapfrog, and I'm here to tell you a little bit more about advanced printing on the Creator HS specifically, or in general. Frank, if you could open up the first slide, please. The first thing what you need to know is when you start 3D printing is material type. Everything stands and falls with the material type. What material are you going to print in? Is it just basically for visual purposes, or are you going to have an actual functional model? Because ABS is a lot harder to print than PLA, and if you're just building a visual model, it's a lot easier just to use PLA for that. And we also have flexible filament now in our stock. There's a small adapter you can place on the printer, and so you can print 3D print flexible materials. Also material quality. There are several suppliers with different materials on the market, and you want to know for sure that you have the absolute best premium quality filaments available. If you use cheap filaments, of course your print is going to be worse than professional filaments that Leapfrog specifically looked after. If you look at cheap PLA, after a while it starts breaking. It snaps, and that means that the PLA is saturated with water and it's getting old. And if you try to print with that material, of course your prints are going to look worse. So make sure you have absolutely the best filament to start with. The filament is the basics of your 3D print. Excuse me for looking to my side, but there's my cheat sheet. Well, for the next sheet, Frank, we have work clean. Make sure that your printer is clean. Wipe your nozzles and make sure you have a fresh and clean bed with a nice clean sticker to work with. And you have to purge your hot ends of any residue old material. It's really hard to start printing PLA when you have residue of ABS still stuck in your hot ends. So make sure that you purge your hot ends of any residue and wipe your nozzles with a cloth. After that, calibrate your printer. Make sure that the printer is doing what you want. So you have to get to know your printer and your materials, because each material prints differently. ABS prints differently than PLA, and sometimes you have to change, for instance, your extrusion multiplier. And make sure that everything is leveled and calibrated. I will give you a short introduction on how to calibrate the 3D printer. With our standalone version, when you press home, the printer will start homing, and the bed will come up. What you will see is that the bed will drop down after that. This is specifically done because if the hot ends are going to heat up, it's not touching your build plate. So there's a gap between it. So it lowers the bed. But that makes calibrating without a PC really hard. There's a small trick I'm going to show you. First, you move your head backwards, and you can see inside the printer there's a small Z sensor. If you move your belt, your timing belt, on the bottom gently, you can move the bed up. And if you move the bed up until the sensor light, there's a small LED on the sensor, wait until that sensor light goes on and find the exact switching point where the sensor goes on and off. And then you found the exact point where the printer will stop. After you found that exact point, you can gently move your printer head forwards, all the way to the right. And now you can adjust with the knobs underneath, you can adjust the level of the bed compared to your nozzle. You can gently move your head to the other side, do it again, move it all the way back, then again, the rear knob you can adjust, and you can fix that exact point where the nozzle is just barely touching the bed, also to the other side, and once you're done, then you're level. So that's on how to level your printer bed without hooking it up to a PC. After that, I want to talk to you about the first layer. Excuse me for looking to my side to my cheat sheet. The first layer is crucial. When you start 3D printing, always make sure that your first layer is absolutely 100% accurate. As soon as the first layer is not stuck to your bed properly, or it's warping or shifting, or small crumbs are appearing, you can stop printing because it will only get worse and it will drag your print off your bed. For the next slide, Frank. The next slide, I'm going to talk about bed adhesion and preparation. Removing the print sticker. Removing the print sticker, placing the print sticker, removing the bubbles, and degreasing your bed. Okay. The tips on removing your print sticker. If you remove the print sticker from your print bed while the bed is hot, a lot of more glue will stick to your bed from the print sticker. So make sure that when you pull off the sticker that your bed is cold. With a cold bed, you won't get as much residue of the print sticker on the bed. It will come off a little bit harder, but you will take most of the glue off. After that, you want to clean the residue of print sticker. The way you can remove the best way you can remove the residue of glue that is still stuck to your bed is heat up the bed around 40 degrees Celsius. After that, you use some regular kitchen cleaner, just pour it on there and use a spatula, and with the spatula we'll just wipe the residue of the print sticker, the glue. You would just wipe it until it comes off, and you can scrape most of it off. Clean it with a cloth. After that, use a simple window wiper, spray it on there, use a cloth, and then move it off until your bed is absolutely clean again. If there's any sticker residue still on your print bed and you place a print sticker over it, you will get bumps, and those bumps you cannot remove. And of course, that's going to mess up your print. So make sure that your bed is absolutely clean before you place a sticker. After this, I want to show you how to place a sticker. From Leapfrog, we have these amazing stickers. They work perfectly for sticking your print to the bed. Before placing your print sticker, make sure that you want to know where you're going to place it. You're going to make a large print. You want to have 2 stickers behind each other. If you're going to make smaller prints, it's easier just to have 1 single sticker in the center of your bed, and make sure in the software that also your model is on the sticker and not next to it. The simplest way to put a sticker on your bed is remove the side tab from the sticker, like this. Align the sticker on your bed where you want it. And rub the side from the side that still has the paper on it outside, and gently wipe it like this so you won't get any air bubbles underneath. Now comes the easy part. Move it up, and while you fold it over, I hope you can see it, you just fold over the whole sticker, push it down, and then swipe it sideways. And that way, you will hardly get any air bubbles underneath. That's the easiest way to put on the sticker. If you do get any air bubbles, you can push them outwards. And if you can push them outwards, you can always, with a small knife, you can cut the air bubble and just move the air out that way. Make sure there's no air, because also air trapped underneath the sticker will create a bulge. And when printing, especially the first layer, the nozzle will tear up that bulge and will tear up your sticker, and that will mess up your printing. So once your sticker is placed, sometimes the material still won't stick to the sticker because you have grease on your fingers. The small grease from just wiping the sticker down and pushing it down, the grease from your fingers will get on the sticker. And that way the filament won't stick to it because it's greasy. If you have simple alcohol wipes, they're really cheap. Use an alcohol wipe and briefly just wipe it. If you wipe it really hard, you will remove the top layer. So make sure you just wipe it like that and it's done. Okay. After that, bed adhesion. That's the first thing I want to talk about. When you start a print, make sure that you have enough surface area of a print on your bed. So if you have a really small object that's really tall, you're going to have a lot of momentum on the top. And if you have a really small area of attachment on the bed, your object might be moved over by the head and it will fall off. So make sure that the surface area on your bed is as large as possible, especially for support structures. Support structures are usually just a Z with a small tiny little line. That tiny little line only has a small surface area of attaching to the bed. So make sure you put a raft or a brim underneath so that also your support material is attached to the bed properly. Because as soon as anything comes off, your whole print basically can be messed up. After that, alternative adhesions. We sell the print stickers because we know these are absolutely the best. But some people swear with other methods of sticking an object to their bed. The most famous one is the blue painter's tape. Blue painter's tape is cheap, you can buy it anywhere, but it has some disadvantages. The most common disadvantage is when you pull off your print, underneath, on the bottom side of your print, you can still see the tape, because you will pull off a piece of tape and it will be embedded inside your print. So you will always have that little blue fluffy stuff on the bottom. You don't want that. So that's why we use the print sticker. Other method is hairspray. Hairspray on the glass bed will work, but the only problem is when you spray hairspray inside your printer, it will get on your rods, on your bearings, and after a while your printer will get clogged and it will stop working as good as it should. If you're going to use hairspray, put a box inside and spray it and make sure that there's no hairspray on any moving parts of the printer. Another famous part is ABS sludge. People use nail polish remover in combination with ABS and make a sludge and smear that on the bed and use that as an adhesive. You can do that, but for me personally, I think it's really messy. Another one is wood glue or glue stick, and use that on the bed, but also it's pretty messy and I wouldn't recommend it. My recommendation, especially the print stickers, they work the best. Okay, Frank, if you go to the next slide. Thank you. How to get the best print results with the level of detail. Tips on the detail of your 3D print. I cannot stress this enough, but you cannot print anything smaller than your nozzle. It's the same as a milling machine or a lathe. You cannot make anything smaller than your tool. Our tool in this printer is 0.35 millimeters. If you're trying to print features that are smaller than 0.35, it will not work. And as you can see on the slide, if you have letters, for instance, protruding on an object or embedded in an object, the nozzle has to cross between, in this case, the E and the T, the nozzle has to pass between there. So make sure that all your features where your nozzle needs to print are bigger than 0.35. If the letters are extruding from an object, you won't have the problem because the nozzle won't have to go past the two letters. It will only do that on the bottom layer, and after that it will build up the letters. So make sure that your 3D print has the features according to the size of your nozzle. People always want to print jewelry and really tiny things, and that's just not possible with something that's 0.35 big. We will soon have smaller and larger nozzles available. We're currently working on that. So we'll have 0.2 millimeters nozzles, but also have bigger ones for the bigger prints, 0.5 nozzles. And we're still working on that, but they will soon be available on the website of Leapfrog. Next slide. Also, the level of detail, the layer height. People always want to print fast. And with the Creator HS, you're already printing 5 times faster than regular. So my advice is, on small objects, use the smallest Z layer height that you can. On larger objects, you can get away with larger Z height. So the smaller your model, also in Z, the smaller the layer height. Don't try to print small objects with big layer heights. As you can see on the example of the bunny, that will look horrible. Next slide. Also, some common mistakes are, as you can see in the first picture, too small size. If you have really small, thin structures, the nozzle will go from structure to structure and it will heat up and it will melt and it will tear, and you can see you get a horrible print. Also, cooling. Cooling is underestimated. Make sure that your object is properly cooled. And then the third one, as you can see, layer height. Really tiny objects with a big layer height look horrible. Next slide. Now I want to tell you something about the tolerances on fitting two parts together. If you print something that's absolutely round, 10 millimeters with a diameter, and print a hole of 10 millimeters, and you try to fit it together, it won't fit. Why? Because both of them are 10 millimeters. Well, as you can see in the slide in the first picture, the left bottom, you can see that the nozzle is pushing out the filament a little bit. It's not pushing it on 0.35, but it's pushing it out a little bit. And if you have a circle, for instance, you can see it in the second picture, it pushes it inwards a little. So a circle will also always have a little bit smaller inner diameter and also have a little bit bigger outer diameter. You can account for that by making your model already bigger or smaller, so you can have an absolutely right amount. But this is also connected to your layer height. So I cannot tell you, you always have to do this or always have to do, I have to do this or that. But the general rule of thumb is that you have a 0.2 difference between an outer and an inner diameter of two parts, and they will fit together. But with larger or smaller layer heights, this might differ. So you have to experiment on how to get the exact diameter that you want. For the next slide, to get the best results from your software, the first part is orientation. How to place your print on your bed. Sometimes it works on, the first part is to find the biggest flat surface to lay on your print bed. And sometimes it will mean that you will have to cut your objects in multiple parts to get a surface area that can fit to the bed, and afterwards glue the parts together. And sometimes that necessarily doesn't mean that the model is upright. It could be upside down or on its side on a weird angle, but make sure that you have the biggest surface sticking to your bed. If you don't have a large surface, use a brim or a raft. Face overhang. Make sure that the face overhang is always pointing backwards towards your slide. And as you can see on the slide, account for gravity. If you have a 45-degree angle, you can print without any support. If you have a larger overhang, you need support. And always place the overhang as much as possible. Sometimes you have overhang on all sides, but if you have it on one side or one side particularly, try to place it to the back of the printer because that's where the fan is blowing and the layer needs to cool down as fast as possible. Also bridging. Between 2 points, you can get away with a small bridge and it will gap it. From one side to the other, it will pull some strings and after that it will build up your model perfectly. But if it gets too big, the bridging, your filament will start to hang and droop, and then you need some support structure. Model structure. Make sure that your model is integer. Make sure that all the faces are pointing the right way. First part is mesh resolution and polygon count. Make sure to export your STL file with the correct resolution. If you export the circle consists of an infinite number of points. If you try to export it with that infinite number of points, your software is going to have a really hard time slicing it. If you export it with too less of points, you will get that flat edges on your circle. So I cannot tell you this is exactly the right amount of resolution that you have to export. That's also linked to the size of your object. If you build a large object, you need a higher resolution. And if you print a smaller object, if you print a circle, those little flat faces are less apparent. So I cannot tell you this is exactly the right amount of resolution. You have to do some experimenting on what's the best. For me, basically, what I usually use is a standard resolution of 0.02 when I export it from the software that I use. But every software has its different way of exporting an STL file. Avoid infinite small lines, intersecting faces, wrong geometry, and holes. If your model has a hole in it, if there's a surface missing, the slicing software will not always be able to interpret what to do with it. It needs a stable an outside surface that it can work with. If there are any holes or if there are any faces intersecting each other, the software that slices your model can get messed up. Most of the models are not that great. The free models you can download on the internet. The free models, people have been working hours and hours to model it and they share their model, but they don't necessarily always have the right knowledge to share that model or intentionally try to mess up the model and go like, yes, I share the model, but yeah, you cannot really use it. So it's not always said that if you download a free model, that is actually okay. So make sure that your model is 100% accurate. Check your part after slicing. You put your model on your bed and put all the elements in for your printer to know what to do with it. But a really valuable feature is after you slice it, run through your model step by step and see if it's actually doing what you want. In the pictures below, what you see is you have on the left, right, it's too small. The text is too small. You can already see on the lines that the printer is going to skip certain parts of your model. Then you know, hey, my model is too small there or it's not printing there. So always make sure that after slicing, you just quickly run through your model and see if everything's okay before you start printing. This is a really valuable feature. Finally, on the software, how to get the best results. Play with your printer. Try out different things. There is not a certain set of settings for your printer. Say, okay, this is absolutely 100% accurate, because sometimes your model is bigger. Sometimes the model is smaller. It might have thin walls. It might have thick walls. It might be printed thin-walled out of ABS or thick-walled out of ABS, and that has a totally different property. Make sure that when you play with it, you get to know your printer and know something and play around with temperatures. You can print PLA at a really high temperature, at 230 degrees. Everybody says print PLA at 190. No, you can print it at 230. That's really high. PLA will get really runny. But then you have a problem with overhang, for instance. But for other instances, it might work just to have a higher temperature. Extrusion multiplier. Some materials ooze more than others, and different materials extrude differently. So try the extrusion multiplier. With the extrusion multiplier, you can dictate the printer to use more material or less material. And that also is dependent on your speed, type of material, and temperature. You have to play with that feature. The extrusion multiplier, if you move it up, it will extrude more. And if you move it down, it will extrude less. And sometimes you want a little bit over extrusion, and sometimes you just want a little bit under extrusion. So don't be afraid to play with the extrusion multiplier a little bit and find the best setting that works the best for your material and your print. Retraction and extra restart values. Some materials are oozing more. If you're printing PLA at a high temperature, it will drip out of your nozzle more. And if you print at low temperature, it won't drip as much. So what you want to try is with the retraction values. Increase the retraction values and make sure that the printer is pulling back the material out of your nozzle so it won't ooze into the other nozzle in the other print that you're printing with your other nozzle. So with the retraction values, you can always play. And also after retraction, the printer will push back the filament into the nozzle. And there's a feature that's called extra restart distance. And you can increase that restart distance. So make sure that when it starts printing with the other nozzle, when you're switching nozzles, that it actually starts printing and not that it makes first a couple of runs with a dry nozzle. So the restart value, you can increase that to make sure that the nozzle is actually restarting. But if you increase it too much, it will create a blob when it needs to print. So there again, it's dependent on material and temperature. So don't be afraid to change that value and play around with it a little bit. Printing speed. Sometimes you need to slow down. Sometimes you need to slow down to make sure that you have the absolute accurate print. Our printer runs at a really high speed, but of course, this can mean also inaccuracy. It is really accurate at high speeds, but when you're printing at a really high speed and it has to make corners, you can imagine that the print head has to stop and start instantly, and it will become a lot harder. If it prints circles, then you can go full speed and it won't matter. So play around with the print speed. Move it down, move it up, see what works best for your model. Cooling values. Give your printer the time to cool down. Give the printer the time to cool down the print. Make sure that when it prints something, make sure that it cools down. Okay, now I want to talk about PVA. Printing with PVA. A lot of people see PVA as the holy grail. It's a simple material, you can print it, and you throw it in the water and it will dissolve. But PVA has some drawbacks. If you show the slide, Frank. The problem with PVA is that it has a really, really small working range. The melting temperature is around 200 degrees, and the point where it will harden is around 215 degrees. So you have a really small bandwidth to work in. So it's really hard to make that material just enough to print and not solidify inside your nozzle. Some tips and tricks on this is don't let it sit in your hot end at high temperature. When you're printing with PVA as a support structure, sometimes it sits in your nozzle while it's printing the material, the PLA or ABS you're working with. It's sitting in your nozzle, and that will create more temperature, and the temperature will rise above that 215 degrees, and that will make it solidify in your nozzle. So make sure when the head is not printing, it's retracted all the way out, and make sure that it's retracted as far as possible without creating too much delay. But the temperature, if it sits in your nozzle, will rise and rise, and it will increase, and it will become above that 215 degrees. Nozzle jams are common with PVA. Because PVA has such a small bandwidth to work in, you can make sure that eventually sometimes your nozzle will clog. Make sure you have plenty of spares and that you don't have to wait for the middleman to deliver the new nozzles that you ordered after a jam. So when you start with printing with PVA, make sure you have enough backup nozzles for the case you have a jam. You cannot clean your hot end by heating it up higher. PVA, the higher you heat it up, it will just solidify more. So as soon as you have a clog, the only way to declog it is to get your nozzle out and use a small piece of guitar string, and you can get the jammed PVA out of your nozzle. Another tip is keep the PVA absolutely dry. Make sure it's stored in a bag with some silica gel. PVA will absorb moisture from the air. If your PVA is just sitting on a shelf, it will absorb moisture. And once it absorbs moisture, you cannot use it anymore. It will not print at all. So the best thing you can do is, if your PVA has attracted moisture, is put it in an oven and gently bake out the moisture. For more tips on PVA printing, I can direct you to our website. It has a solution on PVA printing, and all of these points are also described on our website about PVA printing. And when you think about printing with PVA, consider the alternatives. PVA, because it's so hard to print with, you can use, if you're printing PLA, you can use PLA support structure. If you're printing ABS, you can use ABS support structure, or print ABS with a PLA support structure. You can mix and match other types of support structure. Because PVA, you should only use PVA if there's no other way you can use the support other than soluble PVA. Now I want to talk something a little bit about nylon. At Leapfrog we sell nylon material. And nylon is a really sturdy material, and it's really nice. It prints really nice, but it's also really hard to print. But you can get some good results and some sturdy materials with just printed with nylon. Nylon has some drawbacks, and it has special characteristics that you have to take into account when printing. Nylon prints at really high temperatures. You need around 240 degrees to print nylon, and it warps really a lot. Nylon warps even more than ABS. ABS warps, but nylon really warps. So print at high temperatures, 240 degrees from your nozzle. And you can use, we sell the dust cover for the Creator HS. You can put over the machine to trap the heat inside your printer and make sure that the warping is kept to an absolute minimum. Use a very hot bed. Your heated bed needs to be around 70 to 80 degrees, and do not switch off the bed during the print. Sometimes you see in a G-code that the bed heats up, you start printing, and after layer 5 or 6 the bed switches off and cools down because it's already stuck to the bed. With nylon you absolutely want the bed on the full entire time of your print. Use an insanely large brim or raft. Nylon will warp even the print sticker off your bed, so make sure that you have a really large raft or a really large brim to make sure that your model stays flat. If it will start warping, it will start warping at the edges. And what you can consider is making a brim or a raft from multiple layers. Usually a brim is only 1 layer thick. For nylon you can make a brim 2 or 3 or 4 layers thick. And again, also same as PVA, but even more, keep the nylon absolutely dry. It absorbs more than 10% of its own weight in water in less than 24 hours, just from the air. So if you let it sit for 24 hours on a shelf without anything, it will absorb 10% of its own weight in water. So make sure that the nylon is kept in a sealed bag together with some silica gel, And if you have you expose your nylon again to the air and it's absorbed water, make sure that you bake it out in an oven. Do not cool. While printing nylon, you can keep the cooling fan off. That's going to be a lot harder on overhang, but because nylon cools down so fast, the same as ABS, because it cools down so fast, that's the reason why it warps. So you don't really need the cooling fan in most cases. And for the final thing is pimp your model. Your visual representation, a 3D print is not always the final product. You can make a really nice 3D print, but there are so many options what you can do after printing your 3D print. You can use a spray filler and after that sand it or use a Dremel tool. You can use lacquer, model kit paint, water-based paint, clear coat, anything, and with that you can almost remove the layers completely and can make a really nice visual representation. And you can find exciting new finishes yourselves. On 3D hubs, there was just recently, I saw this guy who used model train flocking on his model. You can see it on the most right picture. He used it's a grass imitate. He used that on his model, and it gave a really exciting outside finish. He sprayed it with spray glue, and after that used the train flocking. That's absolutely amazing. Next slide. And in the end, I only want to state is there is no final solution. I cannot tell you this is absolutely what you have to do to get an absolutely perfect print, because each model is different, each material is different. So to tell you this is absolutely what you have to do to get an absolutely perfect print, you have to get to know your printer. Every material prints different. Even some materials with different colors can print differently. If you print a black PLA, it's going to print a lot different than white PLA or silver PLA, even if it's the same brand. So make sure that you find the material and the color that prints the best for you. And every model prints different. Wall thickness, infill percentage, orientation, overhang. There are so many factors that are into play when you start a 3D print. And all I can say, and that's the final note, is get to know your own machine and materials. Because you have to learn how to 3D print. Everybody says, well, everybody can 3D print. No, you have to, like a CNC machine, you have to learn how to master your machine. You have to get in there and you have to experiment with temperatures, with materials, and have to experiment and try and change values and see what happens. Because as I said, there is no final solution, and the only solution is experience. So get experienced and happy 3D printing.
Well, thank you very much, David, and thank you all for staying in touch with us during the webinar. Hopefully, David had some useful points for you that can help you 3D print. Now, last word I want to say is that maybe after watching this webinar, you got interested in the HS. We want to provide you with a coupon code. I will show it to you on the slide as well. So, yes. So if you use the coupon code that says printer 10 at our web shop, you will get a 10% discount on the printer. Now, if you got interested in the filaments, perhaps you want to try and print with nylon, or perhaps you want to try and print with PVA, you can use the coupon code filament 17. Now, these coupon codes will be valid for 1 week. Further on, I want to explain that we want to do these webinars more frequently. So we have the next session, the 30th of April, and this is for engineers that want to start with 3D printing. So we're going to cover the basics of 3D printing. Also, we did some research at large engineering companies such as Airbus and Philips, and we try to map how they use a 3D printer in their working processes. And we have some real life cases we are going to show during this webinar, the 30th of April. So if you want to join, or if you have friends or family or colleagues that want to join, just send in the links, sales@lpf4g.com, and subscribe for this webinar. So far, all I wanted to say. Thank you very much for watching, and we hope to see you next time. Bye-bye.